Hello everyone. We are Satyajahnavi Ande and Sai Gayatri Bodpati from Sri Vishnu Engineering College for Women. Now, we are going to give a PowerPoint presentation on operating system services. What does operating system mean? An operating system, also known as OS, is software that manages computer hardware. Operating system provides basics for application programs. Operating system also provides services for computer programs. Operating system serves as an intermediary between users and the computer hardware, facilitating the execution of software applications and the overall management of system resources. Some examples of operating systems include Windows, Mac OS, Linux, and Android. Operating systems provide various services to facilitate efficient and secure computer operation. These services collectively ensure that a computer's resources are utilized effectively and user and application programs can interact with the hardware in a streamlined and secure manner. Now, let us see about the services provided by the operating system. In spite of all the services provided by the operating system, there are few major services. They are user interface, program execution, I/O operations, file system manipulation, communication, and error detection. User interface. This feature enables users to interact with the operating system. User interface takes two forms: Command Line Interface (CLI) and Graphical User Interface (GUI). In Command Line Interface, we provide text commands in order to perform certain tasks. In Graphical User Interface, it is mostly used and user-friendly. Program execution as a service in an operating system involves managing the loading, scheduling, and execution of programs or processes. Loading programs. The OS is responsible for loading programs into the computer's memory RAM from storage devices such as hard drives. It ensures that the necessary parts of the program, including instructions and data, are loaded into memory before execution. Process scheduling. The OS employs scheduling algorithms to determine the order in which programs are executed on the CPU. Multitasking operating systems can switch between different programs, allowing several processes to appear as if they are executing simultaneously. Execution control. The OS monitors and controls the execution of programs, ensuring that they follow predefined rules and do not interfere with each other. It allocates CPU time to each program based on the scheduling algorithm in use. Error handling. If errors occur during execution, the OS may detect and handle them. This prevents a single program or process from causing the entire system to crash. Termination. Once a program completes its task or is terminated by the user, the OS ensures that resources allocated to it are released. It may also perform cleanup activities such as closing open files or releasing memory. In summary, program execution involves the orderly loading, scheduling, and execution and termination of programs, providing an environment where multi-processes can run concurrently and efficiently share system resources. I/O operations or input-output operations as a service in an operating system involve managing communication between the computer and its peripherals. Device recognition. The OS identifies and recognizes peripheral devices such as keyboards, mice, storage devices, and printers. Device drivers. Device drivers are used to facilitate communication between the OS and specific hardware devices. The OS interact with these drivers to perform I/O operations. Buffering. The OS often uses buffers to temporarily store data during I/O operations. This helps in smoothing out the speed differences between the CPU and I/O devices. Caching. Caching involves storing copies of frequently accessed data in a faster storage location, example RAM. This helps improve overall system performance by reducing the need for repeated I/O operations. I/O scheduling. The OS schedules and prioritizes I/O operations to optimize the use of resources and reduce waiting times for devices. Error handling. The OS detects and manages errors that may occur during I/O operations, helping prevent data corruption or loss. Interrupt handling. Hardware interrupts notify the OS when a device has completed an I/O operation or requires attention. The OS handles these interrupts to ensure timely processes. File system interaction. The OS manages reading from and writing to files, providing an abstraction layer that allows programs to perform I/O operations without needing detailed knowledge of the underlying hardware. Access control. The OS enforces access controls to prevent unauthorized processes or users from interfering with I/O operations. I/O operations thus ensure efficient and secure communication between the computer and its peripheral devices, offering a standardized interface for software applications to interact with various hardware components. File system manipulation. File system manipulation as a service in operating system involves various operations related to organizing, accessing, and manipulating files and directories. File creation and deletion. The OS allows users and applications to create new files and delete existing ones. This includes handling permissions and ensure proper file removal. Directory creation and navigation. Users and applications can create directories to organize files. The OS provides commands or APIs for navigating and managing the directory structure. File renaming and moving. The OS supports operations that allow users to rename files and move them to different directories, facilitating organization and management. File copying. Users can copy files to duplicate them either within the same directory or to different locations. This operation is useful for creating backups or transferring data. File attribute modifications. The OS provides mechanisms to modify file attributes, include permissions, ownership, and timestamps to manage access and track changes. File access control. Access control lists ACL or permissions are managed by the OS to regulate which users or processes have read, write, or execute permissions on files. File search retrieval. The OS offers tools or APIs for searching and retrieving files based on criteria such as file names, types, or content. File compression and encryption. Some file systems or OS features allow compression and encryption of files to save space and enhance security. Symbolic and hard links. The OS supports the creation of symbolic and hard links, allowing multiple references to the same file. This aids in efficient resource utilization. Transactional file operations. In certain scenarios, the OS supports transactional file operations, ensuring that a series of file manipulations either complete successfully or leave the system in consistent state. Batch processing. Operations such as renaming multiple files or applying changes to a group of files can be performed in batches, enhancing efficiency. File system manipulation services thus plays a crucial role in providing users and applications with the tools to organize, access, and modify data in structured and secure manner. Error detection. Error detection as a service in operating system involves mechanisms to identify and handle errors that may occur during various system operations. Fault detection. The OS continuously monitors system components, hardware, and software for faults or abnormal behavior. Hardware errors. It detects hardware errors such as memory corruption, disk failures, or communication errors with peripherals through various error detection mechanisms. Software errors. The OS identifies and handles errors in software execution, preventing them from causing system crashes. This includes errors in application programs and system software. Exception handling. The OS sets up exception handlers to deal with abnormal situations such as division by zero or invalid memory access, preventing these from causing system instability. Error logging. When errors occur, the OS may log relevant information about the error, including timestamps, affected processes, and error codes. This log can be useful for system administrators and developers during troubleshooting. Error recovery. The OS may attempt to recover from errors gracefully, either by restarting a failed process, reallocating resources, or initiating corrective actions to restore normal operation. Watchdog timers. Watchdog timers are used to detect and recover from system hangs or unresponsive states. If the system fails to reset the timer within a predefined interval, it triggers a corrective action. Data integrity checks. The OS ensures the integrity of data by employing methods such as checksums or cyclic redundancy checks (CRCs). This helps detect and correct errors in data storage and transmission. Network error handling. For systems connected to networks, the OS identifies and manages errors related to network communication, ensuring reliable data transfer. User input validation. The OS may validate user inputs to prevent errors that could compromise system stability or security. File system integrity checks. Regular checks and maintenance activities are performed to ensure the integrity of the file system, preventing and correcting errors in stored data. In summary, error detection is crucial for maintaining system stability, preventing data corruption, and facilitating a more robust and reliable computing environment. The last service of the operating system is communication. Communication as a service in an operating system involves facilitating communication and interaction between different processes or components within the system. Inter-process communication, also known as IPC. The OS provides mechanisms for processes to communicate with each other, such as message passing, shared memory, or signals. Synchronization. The OS ensures synchronization between processes to avoid conflicts and race conditions. This includes managing access to shared resources to prevent data corruption. Signals and events. Processes can use signals or events to notify each other about specific occurrences or to trigger particular actions. Message passing. Processes can exchange messages through mechanisms like pipes, queues, or sockets. This enables communication between processes running on the same system or even on different systems. Named pipes or FIFOs. The OS supports the creation of named pipes and first in first out, also known as FIFO buffers, allowing processes to communicate through a common named channel. Shared memory. Processes can share a region of memory to exchange data directly. The OS manages access control to ensure proper coordination. Remote procedure calls, also known as RPC. In distribution systems, the OS may support RPC mechanisms, allowing processes on different machines to call functions or procedures remotely. Socket communication. Sockets provide a communication interface between processes over a network. The OS manages socket creation, binding, and communication for network applications. Semaphore and mutex. The OS offers synchronization tools like semaphores and mutexes to control access to shared resources and prevent conflicts. Message queues. Processes can use message queues to send and receive messages asynchronously. This helps in building more loosely coupled systems. Interrupt handling. Communication is facilitated through hardware interrupts, allowing devices to notify the operating system of events that require attention. Effective communication services are crucial for creating a cohesive and collaborative computing environment, enabling different parts of the systems to work together harmoniously. Thus, operating system services encompass crucial functionalities that enables efficient and secure computer operation. These services include program execution, managing input and output operations, file system management and manipulation, error detection and handling, interprocess communication, memory management, process management, networking, and security measures. Together, these services provide a structured environment for software applications, ensuring effective resource utilization and user interaction within a computing system. Thank you.